Hey, we're going to talk about how to factor general trinomials. This is in our notes packet P.3 and P.4. On the page that starts with example 8, this is the lower portion of the page. So factoring general trinomials, so there's three terms, that's why it's a trinomial. And it's not a perfect square trinomial. Remember, a perfect square trinomial, this first term is a perfect square, the last term is a perfect square, and the middle term is 2 times the square root of the first term times the square root of the third term. So we're not talking about one of those special patterns. Okay, in this case, we're going to use this factoring pattern. We have ax squared plus bx plus c. The first term in each of the binomials, those terms are going to be factors of a, and the last two terms are going to be factors of c. And that's a method that will help us factor. The goal is to write the trinomial as the product of two binomials, right? Two terms in each set of parentheses. Something x plus m, where m is a constant. Something x plus n, where n is a constant. If the leading coefficient is 1, then our work is much simpler. And this simplifies to x plus m times x plus n. Both of these constants coefficients will be 1. And we look for two numbers, m and n, that multiply to c, which is the last term, and add to b, the middle term. Okay? If the leading coefficient is not 1, then there's two methods we can use. One is guess and check, and the second is what you guys probably call the AC method, which is actually factoring by grouping. In this method, we rewrite the middle term as two terms, by choosing factors of the product a times c that add to b. This is explained on page 37 of our textbook, and we'll do some examples on the next page. Always, always, always remember to first factor out the greatest common factor. Okay, that's always the first step when we are factoring. Okay, so flip to the next page, and we're going to do some examples of factoring trinomials. Okay, the first one, we have x squared minus 6x minus 7. In this case, the leading coefficient is 1. So we're going to look for two numbers that multiply to negative 27 and add to negative 6. So if we think about those factors, we'll discover that they are negative 9 and 3, because negative 9 times 3 is negative 27, negative 9 plus 3 is negative 6, and we use those numbers to create our binomials. So we have x minus 9 times x plus 3, and then we can check our work by distributing, expanding this out. So let's do a quick check. So we can FOIL this, I guess you could say. And we have our first two terms, so x squared, the first, the outer, plus 3x minus the inner 9x, and then plus the last. So first, the outer, inner, last would be minus 27. Combining like terms, we get x squared minus 6x minus 27. Check. So we can always check our work by simply distributing and make sure that we got what we started with. In the next case, we have example B, 9b, 3x squared plus 11x plus 10. Here, the leading coefficient is not equal to 1. That makes our life a little bit more difficult. Two methods. The first is guess and check. Some of you may not be familiar with guess and check. So in guess and check, we know that we're going to have two binomials. The first two terms have to multiply to 3x squared. So I don't have any other choice but to put 3x in x. The last two terms have to multiply to positive 10. So I want factors of 10. Usually I choose factors that are closer together. So I have 10 and 1 and 5 and 2, or negative 5 and negative 2. So I'm going to guess that there are 5 and 2. Both positive because I have a plus 11x, and then I have to decide, I have to guess whether I should put the 2 in the first set of parentheses or the 5. You can do it either way, or you can think about what might happen. So I'm going to put the 5 in the first and the 2 in the second, and now we're going to check. To check, I need to check the OI terms, as I call them, so the outer and inner terms. So I already know the first terms are going to multiply to 3x squared, and the last terms are going to multiply to 10. That's how I chose these terms. But 5 times x is 5x, and 2 times 3x is 6x. Together, those are going to add to 11x. So this works. The other way is the AC method. So for the AC method, what we're going to do is we're going to multiply A, which is 3, and C, which is 10. So AC, which is probably how you learned it, it's going to be 3 times 10, which is 30. And then I want numbers that multiply to 30, but add to 11. Those are 5 and 6. So I'm going to split the 11x into 2 terms. So I get 3x squared plus 6x plus 5x plus 10. It doesn't matter which order you put them in. And then I'm going to group the first 2 terms and group the last 2 terms. And I'm going to take out the greatest common factor from each set. So the first 2 terms I'm going to factor out a 3x, leaving me with x plus 2. The last 2 terms I'm going to take out the greatest common factor, which is a 5, leaves me with x plus 2. The x plus 2 is a common factor to both terms, which means we can factor that out, leaving us with 3x plus 5 times x plus 2. So the AC method always works. Sometimes if the A and C are large numbers, it can be a little bit more complicated to find the 2 terms to split up that middle term. Example C, 4x cubed minus 8x squared minus 60x. I'm going to see if there's a greatest common factor, because that will make my life a lot easier. So is there a greatest common factor? Yes, there is. The greatest common factor for these 3 terms is 4x. And then I'm going to factor that out, so I'm left with x squared minus 2x minus 15. And now I have a trinomial where the leading coefficient is 1, which is a lot easier. So I look for numbers that multiply to negative 15 and add to negative 2. Those numbers are negative 5 and positive 3. So I can factor this trinomial as x minus 5 times x plus 3, and I bring the 4x down. So that is my factorization. I can do a quick check. So I can distribute 4x here. I'll get 4x squared minus 20x, and then I have to multiply that by x plus 3. That gives me 4x cubed. I'll do the outer terms plus 12x squared. Inner terms minus 20x squared. The last terms minus 60x. Combining like terms, I get 4x cubed minus 8x squared minus 60x, which is what we began with.